Welcome back at our second series of workshops on AI4EOSC development and on the AI development in the EOSC. My name is Marcin Płóciennik. I work at PSNC, and I'm leading activities in AI4EOSC related with the communication. So I will be moderating this session. So we will today going through the AI and LLMs from theory to practice. So we will have today basically four very interesting talks about introducing to AI and LLMs, why AI4EOSC, to take advantage of the platform. Also, you'll V8 demo in AI4EOSC platform, and we will conclude with LM4EOSC in action. Basically, for at the end of each of the this presentation, you will have a chance to ask a question. So here is the QR code that you can take a picture of it, or you can go there directly. You can write your questions during the sessions, and we will, at the end of each presentation, we'll come back to it, and we'll have the question answer session. Basically, we start now with introduction to AI and LLMs. So let me introduce Steven van Warenberg. He is an associate professor in the area of didactics of mathematics at the University of Cantabria. He graduated as telecommunication engineer from the University of Ghent in Belgium, and PhD in telecommunication from the University of Cantabria. So he has more than 10 years of research experience in the field of the machine learning. In 2018, he joined the Department of Mathematics, Statistics, and Computer Science at the University of Cantabria, where he works as a teacher and researcher in didactics of mathematics. So I would like to warmly welcome Steven. Thank you. So the floor is yours. Please start. You can share your slides.
Thank you, Marcin. There goes my presentation. So good morning, everybody. Thank you for being here. I will talk about the general context here, about a little bit about AI, a little bit about LLMs. And obviously, this is a very broad field because everybody is using LLMs now, be it by using ChatGPT or in his or her research. So I will try to give some context here. So first, we should briefly situate this into the AI context. So there you go. So what we have here is obviously AI is not new. When we hear about AI in the news, mostly people are talking about ChatGPT, but there's a whole family of symbolic AI research that has been around for decades. So symbolic AI would be when we have rule-based systems. And then in the last decades, mainly from the 90s, machine learning has started to take its place in the most state-of-the-art methods. So machine learning is basically a different way of doing AI. It's a way of obtaining a model by giving data to the model. So if you give it input and output data, the model learns its own internal rules or its own internal configurations. And if we give it enough data, this is capable of learning or training itself, let's say. So what we will talk about in my talk is machine learning, basically. Now, in the last decade, the type of machine learning we have seen is a type of machine learning where the neural networks grow very big, which is called deep learning. And we have several layers of neurons in the neural network. And these networks, they represent models that can do, they can perform very sophisticated tasks like recognizing images or transcribing text from a speech recording. So One of the deep learning neural networks that is very relevant is the type of convolutional neural networks. These are networks that are designed for image processing. And basically, each layer of the network learns features of the image at a different level. So the first layers will learn basic features like edges of the image. Then edges will be combined by the following layers. And at the last layers, we get neurons that actually that learn concepts that are part of the image. So this is very relevant still because it's used in all modern image processing. And another type of neural networks that's very relevant is recurrent neural networks. So recurrent neural networks are networks that are capable of processing sequences. What they do is they have some internal state and they process the sequence block by block or input symbol by input symbol. And what they do then is they process part of the sequence, and in order to process the next part or the next letter in this example here, they would need the previous state and then process the next one. So it's very sequential. We cannot process one part of the sequence without having processed the entire previous sequence. So that makes it very hard to parallelize, for instance. But this is still very relevant because this is, for instance, what we have in our phones when we dictate something to our personal assistant. This is the text transcription that is happening behind. Now, this is a brief intro to artificial intelligence, but let's talk about language models now, because in this example already we see that we can actually, instead of images or simply numerical data, we can input text to this kind of model. Now, there's one area that has been researching this for a lot of time, which is the natural language processing. Also, linguists study that, but not until recently have they converged to a common field. Now, what we have seen lately is the emergence of large language models. Large language models are a kind of deep neural networks that are capable of performing natural language processing. If we try this with recurrent neural networks, they find some difficulties because, first of all, they cannot be made parallel easily. This means we have to process the entire sequence symbol by symbol, and we cannot split the sequence into subsequences and send them to different processors and process everything in parallel. That is very difficult, usually. Also, if there are relationships between words from the start and the end, this is still pretty hard to detect and to take into account. So somewhere around 2015, people started to incorporate new mechanisms into these architectures, mechanisms that started to directly model the dependencies between parts of the sequence. Those were called attention mechanisms. And what happened later in 2017 is that it turned out that we could actually remove the entire recurrent part and only keep the attention part. That is where the transformer model emerged. Transformer model in the paper, attention is all you need, because we could actually do without the recurrent part. So what we have on this slide is the famous diagram of the transformer architecture. I will not go into detail because there's too much details here. Let me basically say that this is capable of processing sequences in parallel because it doesn't use the recurrent part, and it uses attention mechanisms, which, let me jump ahead one slide for a moment, do something like this. So here in this example, we have to read this in vertical. The colors show what the different attention heads are doing. So attention heads are operations that are performed on parts of the sequence, and they try to determine if one part of the sequence is related to another word. And here we can see several different attention heads that see that the word making is related to them. And then we can see by connecting these parts that it actually finds that this sequence has a core part which is making more difficult. Now, this is obviously behind the screens. It is doing some some linguistic processing, some linguistic modeling. Although it is not based on rules, but simply based on these relationships that are found. The lines here actually represent, the colors represent numbers, which can be interpreted as probabilities. So this is all included in the transformer block. And if we combine several transformers, we can build a neural network, which is capable of modeling sequences and in the end, modeling language. Now, the first one that actually was very popular here was, well, not this exactly one, this is a GPT-1. So the first one that was really popular was GPT-3. All the GPTs actually only used the decoder part. So instead of saying we have an input sequence that we will map to an output sequence, they operate on a single sequence actually, and try to predict that sequence. So let me talk a little bit about what they do then with language, because they work in several steps. So before the words are fed into the model, first they have to be translated into numbers, because internally all these methods obviously operate mathematically. So we take a text and we divide it into small pieces, which are called tokens. We can see an example here. This is a text of 208 characters that is divided into 50 tokens. And at the bottom of this slide, you can see the colors of the tokens. Now, once we have tokens, and typically there are more than 10,000 of those tokens. Once we have those, each token is given an index, which is simply a number. And then step 2 is they are mapped into a space where similar tokens are represented closely. Similar in the sense of semantically similar. As you can see in this example, here we have animals that are positioned closely and on the space, while fruits and vegetables are at other places. Now, in order to embed all these tokens in a way that similar tokens are close together, we need more than 2 dimensions, obviously. And as we can see here, the GPT-3 model already used spaces of up to 12,000 dimensions. Now, that means the inputs to our neural network will be a vector of 12,000 components. And actually, as we have a sequence of tokens, we have a sequence of these vectors that is fed into the model. Now, what the model does then is it learns the order of that sequence, and it is capable of modeling the probability that one particular token will follow the entire sequence as seen up till that point. So that's actually step 3. What the LLMs basically do is they predict text. So if we give it a string, they will be capable of calculating the probability that is a certain token or certain word is the next one. And what happens in practice is that we give it sequence, it calculates which are the most probable words or tokens, and then out of the 5 or 10 most probable words, it takes at random 1. And then it repeats the process so that it actually writes a text word by word or token by token. Now, this is what we know because this is what we've seen in action in ChatGPT, for instance. And if we go back to the diagram, we see that this is actually a subset of deep learning. We have LLMs there. We have also generative AI. There are some LLMs that are not generative AI, LLMs that process text or analyze language, for instance. And there is some generative AI that is not LLM, but basically we will be working in the subset that is part of both. Now, I will talk briefly about the 3 generations that there have been in LLMs or in LLM chatbots. So the datum that OpenAI released is that nowadays there are 400 million users of ChatGPT every month. Now that's a big number. That means more or less 1 person in every 20 of the entire world. That is huge. And it's interesting to see which LLMs we have been using. So first of all, obviously, this started in 2022, November 2022. This was when the world got to know ChatGPT. LLMs have been around for a little longer, obviously, but this is when AI became very popular everywhere. The first chatbots had some limitations. They had a limited context, so if the text grew too long, they actually forgot the start. They had more or less 16,000 tokens. And they also hallucinated frequently. Now, hallucinated, as you might know, means that they write text that is factually incorrect. The LLM does not know this because it always does the same. It invents text, but when we see, as humans, that it produces something that is incorrect, we say that it hallucinates. That was a big problem at the start. Then a few months later came the second generation, which were the models like GPT-4. They had a lot less hallucinations. They produced better programming code. They produced better structured code. They had a very much larger context window. They could use tools like external internet search. And we've seen GPT-3 and then also a lot of other models like Claude 3, Gemini 2. Also a few months ago, DeepSeek version 3 appeared, which is also a GPT-4 level model. So we've seen the emergence of these models. And interestingly, they have multi-model capabilities. Multi-model means that they can process at the same time, for instance, text and image, like we can see here. So this is an example of what we can do with vision. If we combine text and image, we get vision models. What they do basically is they convert text into a latent representation of the text, but at the same time, they convert the image into latent representation of the text. And they map both latent representations into a common space, a common latent space, where it is possible to relate text with image characteristics. And once it builds that space, we can, for instance, through a chatbot, make conversation about the image, like what we can see here. We can ask, is one cat behind another? It has found the relation between the image characteristics and the text here. So that is very useful. And then we saw the third generation. The third generation started to appear at the end of last year. What we saw here is that it's still LLMs, but they start to reason a little better. It's not real reasoning because they don't use symbolic AI behind. They still use LLMs, but what they do is, if we ask them something, they produce an output, but they don't show us the output. They produce the text, and then they will feed that output to their input again. So they will read their input and output again, produce another text, and do that several times until they get a final output. Basically, what they do is write something, then try to reason about it, and repeat that process several times. So they try to think about their own production. Now, all of this happens at test time. That means when we do inference, the data does not pass a single time through the network. Instead, it is fed into the network several times in a recurrent fashion, almost, until the network determines that it has solved the problem. Now, we saw ChatGPT 01 around September last year, and then this year we also saw DeepSeek R1, which is also a reasoning model, and Gemini Flash 2.0 thinking. So these are the models of the third generation. There are many models around. Here's a brief overview. You can visit this link to see the 8 of the most recent and most used LLMs, but there are much more. So to finish this talk, I will talk briefly about how we can use LLMs in our research. Now, obviously, most of us use ChatGPT, so we use it as an assistant in our research, and that is fine. But I would call that some sort of a high-level use. Obviously, we can also use, we can make use of LLMs in a lower-level fashion when we integrate LLMs into our workflow or into our models, for instance. So I'll start at the bottom, which is when we integrate LLMs. Sorry, when we work on LLMs at the code level or at the algorithm level. So that would be the lowest level of the three. If we actually build our own models using transformers, training transformers, maybe adapting networks, then we would be working at the lowest level with LLMs. This is appropriate when the data or the domain is unique. Otherwise, we should actually take a pre-trained LLM and build on that, because working on this level, this lowest level, is pretty expensive, as training requires a lot of computation. So what we would typically do is work on an intermediate level, which is where we could take a pre-trained model, a foundation model, and fine-tune that to our data. That is one way of working with LLMs. What we could do also is incorporate an LLM into our APIs. We could make it part of our own workflow. And I've placed the diagram here of something that is very relevant today, which is retrieval augmented generation, which is what we will do when we, for instance, have a database of text documents, and we want the LLM to respond to us by consulting that text database. That's called retrieval augmented generation. So in this diagram, we can see that we have a knowledge base. Those are the documents, and we have a pre-trained LLM. We will not pre-train this. We will download the LLM or consult it. The retrieval augmented generation will then send the query of the user to the LLM, but it will take into account everything that is contained into the knowledge base. This is very useful for working on projects, for instance, because we can send all the information of the project to the LLM and ask it to limit its answers to information that is inside the database. Now, that's the intermediate level. I will talk about the highest level now, because I think that is what most people use in their daily tasks. The highest level is when we simply use the chatbot. So what we can do is use a chatbot, for instance, as a research partner. This is very useful when we are brainstorming or looking for hypotheses, but we can do more. We can look up literature. We can try to summarize text, and I'm saying try to summarize because it still makes mistakes, so we always have to verify. Interestingly, we can also ask it to criticize our text, or our proposals, our structures. And something that is also emerging now is the use of agents. Agents are LLM-based programs that can operate autonomously. They can help us with processes that could be made automatic, like data collection, cleaning. So I will give a quick example about what agents can do, because as you can see here on this screen, this is ChatGPT, but it's with the Deep Research Assistant. This is something that is starting to appear this year. And well, I could have made a video, but this is something that is an autonomous agent. So you give it an instruction, and then it thinks for a while, and it does its research. So it takes several minutes. So I've included screenshots here. What it does, so I ask it a question: write a literature review on the state of the art in homomorphic encryption. What is homomorphic encryption? It's not really relevant here, because I don't even need to know. I'm just asking it to write a literature review. Now then it will say that, well, first what it will do is it will ask me questions to know better what I want. And as a side note, this is actually an interesting tip. We should always ask the chatbot to ask questions to ourselves, so that it can learn more about what we want actually. Here, this is embedded, so it will always ask questions. For instance, here, once I answer the questions, it will start reviewing literature. We can see that there's a loading bar. It says it has been seeing 13 sources already. Some minutes pass, and then after 7 minutes here at the top, we can say it has researched. It has completed the research. In 7 minutes, it has consulted 30 sources, and it produced an entire report. As you can see in the text, there are sources cited, so this is not invented. This has been verified with sources. Still, it's an LLM, so we should verify it ourselves. There's an entire text. It even includes figures which are taken from the literature. and it has references. So this is something that we will see more and more, I think, and there's a lot of considerations around this. This is obviously not how we want to produce papers, but it's interesting to see what is possible. Also, in general, we will see these agents appear in other products. Microsoft tries to embed these agents in all of their products as well. So we will see this kind of automated work more and more. Now, last slide about some best practices and some responsible usage. Some best practices here, I would say, try to avoid inputting raw data into the LLM. So, especially if it's an LLM that is based in the cloud. What we should do is, instead of giving it raw data and asking it to process that, because it will make mistakes, we should ask it to help us to build workflows or processing scripts. Also, if we want to use it in writing, we should not ask it to write text, but we should write text ourselves and then ask it to improve the text or criticize it. When we do brainstorming, it's useful to always ask it for multiple options. And then there are two prompting techniques that I would also like to include here. One is hierarchical prompting. So if we do need to produce a text, then we can ask the chatbot to give it structure by first explicitly asking the chatbot to write the structure and then letting it write the details. So this works pretty well. And then the last one is one that I already mentioned. That's inverse prompting. Inverse prompting means when we ask the chatbot to ask us clarifying questions, and then it will ask the questions it needs to know in order to understand our context better. That's also very useful. And one comment about considerations. Obviously, there's a lot of ethical concerns. There's bias in these methods. I cannot go into detail here. There's privacy concerns. We should always know when we use an LLM what the privacy policy is. There's intellectual property concerns. There's energy consumption concerns because training them requires massive energy. Here we have training cost for both of them. For two of them, I mean, it's very high. Inference cost is lower. Actually, it's not that high at all. Here we have the water consumption by data centers, and we see that inference cost is actually very low. If we ask ChatGPT a question, we have here the water consumption, as you can see on my screen, which is much lower compared to a Zoom call. The Zoom call we're in actually produces or requires a lot more water in the data centers than an actual question to ChatGPT. So to conclude, transformers are game changers in LLMs and in all levels of society, basically, and especially in our research. We can incorporate them as building blocks into our research. They're not perfect yet. Also, when they try to reason, they still use language models, so it's not really symbolic reasoning. There's a lot of issues with ethical concerns, etc. The field is evolving very rapidly. If this talk were in 1 month, probably I would have to change a lot of slides. And in the future, we will see, I think, the symbolic AI being included again. So some references, and that is all for me. Thank you very much.
Steven, thank you very much for your very interesting, exciting presentation. We have already a couple of questions. I will now switch to the QR code so others also that joined later could ask the questions. So I will share. I will share now the basically the.
Should I stop sharing?
Yeah, I already have done it. So please, if you have questions, please, you can still post it on the Slido. And I will read first questions that we have there. Could you recommend any specific chatbot or model dedicated to help scientific research? That's the first question.
Scientific research? Oh, well, I think all questions can be, they have different ramifications. So any chatbot or LLM model for scientific research, I understand that you mean as an AI assistant. Scientific research has a lot of different tasks, so let me just go over them. For literature, lookup, I could recommend consensus, which is accessible through the ChatGPT interface. If in ChatGPT at the top left we click the Explore GPT button, we can find consensus, which will help us by resolve scientific questions by looking up real articles. That's for looking up. For scientific research, I mean, this is so broad. The one I showed here, the deep research by ChatGPT, but this is the ChatGPT Plus, it's a paid model. This is interesting also for making preliminary reports about something.
Yes, Stephen, thanks. I think this is already very good to start with, and we have the next question. So it's coming, they're coming. So I'm moving. So what happened to the data input to LLMs?
What happens with the data input to LLMs? Well, if it is text, then it is converted into a numerical representation. So it is split up into tokens. Every token is mapped into a high-dimensional space where it is a large vector, and then the sequence of vectors is fed into the LLM. So if we're talking about a chatbot, so there will be a sequence of tokens, which is actually our input text, and then the chatbot will try to continue the text with his messages. And then if we give it another text, that will go at the end of the entire sequence. So we're forming a large sequence of messages if we're talking to a chatbot. How that answers the questions at a high level?
Yeah, I think yes. So the next question: do we know the training data used by LLMs are legally obtained?
Are they legally obtained? Well, we know that a lot of it is in the gray area because, for instance, there was an experiment 2 years ago, in which researchers found a way of extracting original data from the LLM. It turns out that if you produce a string that is so very unlikely, then the LLM will start producing, basically, it will get to some ground level where the original strings are outputted again. And they saw that actually there were articles of the New York Times that were included. So that led to a lawsuit. The company said it was a gray area. It was not strictly forbidden. But do we know this? Well, first of all, most of the big models are private companies, and we do not know which data they used. Okay. There are some open models, but they are open in the sense of that they give us the weights. They give us the training. Sorry, they give us the neural network weights, so we can implement it in our own computer, like Llama from Meta, which we can implement in all Llama on our computer. But they don't say explicitly. Most of them don't say explicitly which training data they used. So in general, we don't know it.
Okay, so I think that there are really a lot of questions, so I will pick just two more, and then we will conclude and go to the next presentation. So can LLM be used straight on datasets, assuming datasets can be coded as embeddings?
Can you repeat that?
Can LLM be used straight on datasets, assuming datasets can be coded as embeddings?
Well, if it is text, the encoding is typically included in the model. But if you use a vanilla LLM and you have your own data in your own domain, you might and very probably will have to program your own encoding. And let me add that the encoding, or the embedding actually, the embedding is something that has to be learned as well. So if we map them to that latent space, it's not obvious where the different data should be mapped, because they have to maintain those relations, and there's a training problem as well. Which, if you're in a different domain, I think you should do it yourself. You should train that yourself.
Okay, and the last question, can you explain the difference between LoRa fine-tuning and RAG?
LoRa fine-tuning, okay, that's a very technical question. LoRa fine-tuning is actually performed on only parts of the network. This can be explained by how a big matrix is approximated by a multiplication of two very narrow matrices. RAGs, I don't know if I think RAGs don't use LoRa behind them. I cannot explain it at the technical level, actually. Okay. So I don't think that is necessary here. Okay. If necessary, I can look it up and we can write. My email is in the first slide.
Okay, there is also on Slido people thanking you for this presentation, so I pass it to you. So thank you very much again.
You're welcome.
And yes, so we move now to the next presentation, why AI4EOSC take advantage of the platform. I would like to welcome Judith Sáenz-Padrón-Díaz. She's a researcher at Advanced Computing and a science group at the Spanish National Research Council, a mathematician with a major in computer science from the University of Cantabria and master in data science from the Universidad Internacional Mendeles Pelayo. She's developing her PhD thesis in privacy preserving techniques in the data science environment. So Judith, the floor is yours.
Thank you very much, Marcin. Let me share my screen. So thank you very much for the introduction, and thank you very much for all of you that have attended to this talk. As Marcin has mentioned, I'm going to explain why AI4EOSC and how can we take advantage of this platform for making a different training of AI-based model, data-based model, and so on. So first, I'm going to start introducing the AI4EOSC project, that is the project that is working on developing this platform for AI. And this project arises as the evolution of the deep hybrid data cloud platform. It runs during 3 years. We are reaching to the end of the project in the next month of August. So we are in the final phase. The wonderful AI4EOSC consortium has 7 academical partners, 2 small and medium enterprises collaborating together also with a non-profit organization, and the result of a quite interdisciplinary team in developing this kind of models, developing this kind of tools for AI has different interesting results, such as the case of different workshops that we have held on AI, as the one that we are holding today, different peer-reviewed publications that you can find in our page, on our webpage, and different collaboration with a lot of European funded projects. So first, what are the main objectives of this project is to provide users with a set of advanced tools for developing this kind of AI-based applications. And when I talk about advanced tools, advanced features, I mean that users can access to different methods to perform, for example, federated learning training as a way of collaborating, making machine learning models in a privacy-preserving way. Also to perform distributed training of the models when you want to access to different resources. For example, you may need to access to more than one GPU for training your model. Also to other advanced tools, such as monitoring your models using MLOps to be able to detect if your model is suffering from certain kind of drift. Also to make inference with your model, to apply different composite AI applications, to have a metadata provenance catalog, and all in all, to provide the user with these advanced tools. So I'm going to start explaining why do we need this kind of platform, and then I'm going to review all this stuff, taking a look to the, let's say, summarized machine learning lifecycle. So first, why do we need this kind of platform for developing AI? Is because first, the users in some cases may need to have access to the resources, to the computing resources in a quite transparent way in order to be able to develop such model, to have access to more computing resources. Also, when we are dealing, for example, with the development of LLM models, in which we, of course, need to use GPUs and other complete resources. Also, AI4EOSC is in order to provide users with the possibility of synchronizing the data that they may have, for example, in their local repositories. We can think about using a synchronization with open science repositories, such as could be the case of Zenodo, in which the users can have different communities. Then they can synchronize their data with the platform for making the training. Also, they can use this platform for, once they have trained the model, they have the model trained with their data, they can make different inference tasks and then use the model in production. And when we think about putting the model in production, we think about monitoring the model, about MLOps, about drift detection, and that's also provided within the platform in a quite simple and transparent way for the users. In addition, as in this project, in general, when we are making open science, we have to put the focus also on privacy. We provide the users with advanced tools such as federated learning, as I have mentioned, integrating different privacy-enhancing technologies, such as the case of differential privacy, in order to allow to foster the collaboration in a federated way between different data providers, institutions, whatever. Also, in order to the users to be able to benefit of the model provenance metadata that aims to cover the whole machine learning lifecycle, and in summary, why AI4EOSC, in order to help the researchers that are working with AI models and help them also to follow the best practice when they are developing this kind of applications. So the objective of the AI4EOSC project is to develop this AI4EOSC platform. So here you can see the dashboard, in which you can see that there are different tools, different models, but I just wanted to show this screenshot, but I'm going to review not all, but the main components of the platform in a quite detailed way using this machine learning lifecycle schema. So I'm going to start by explaining a little bit why this schema, because it's a simplified one, and then we are going to review the different steps and how can we take advantage of AI4EOSC for the different steps here. So first, when we are developing a machine learning model and AI-based application in which we are dealing with data as our basis, then we have to access that data, have the data synchronized in our virtual machines, in our deployment, in our development environments, etc. And then when we have the data synchronized and we have the data in our machines, then we have to perform the data processing, the cleaning, the curation, or even other techniques such as data augmentation if we need it. Then if we are going to perform this training and we have enough data for making also a test, a validation, we can make this train test validation split in order to be able to train with the trained dataset, to validate and fine-tune the hyperparameters using the validation split, and then we can test and evaluate the model in the test dataset if possible, and in case we have access to it. So then, in this step, we have our data, let's say, ready for starting creating the model, as we have, of course, processed it. And we have to think, okay, first, do I have a model that is available and that I can reuse for making my application? If that's the case, we can go to a model repository and take a reference model and use that existing model in order to then train and validate the model with our new data. So we can make a fine-tuning, we can make a fine-tuning also of the hyperparameters based on our new data. For example, imagine that you want to make an AI-based model for classifying medical imaging of a certain type of medical imaging. Then you can go to a model repository and search for a model that can be used for image classifying or for image segmentation, depending on the task. Then you can fine-tune that model and adapt it to your dataset. However, in some cases, we may need to create the model, let's say, from scratch to create our model and then train it with our data. So in that case, we need to have access to the resources to train the model. We need to have access to a development environment for using different, let's say, frameworks, such as could be the case of PyTorch, TensorFlow, wherever, and then train that model. So once we have the model trained, then we have to move to the step of evaluating the model. So when we evaluate the model, for example, if we have a test split for saying, okay, how accurate is my model? I have to fine-tune it again. I have to make a fine-tune of the hyperparameters. You have to evaluate if it is accurate enough. If it's not, then of course you need to fine-tune it, to retrain, etc. But if your model is finally accurate enough, then you can serve the model. And when you are serving the model, you can put it in production. And this is a quite important step because in most of the cases in which we are working with research applications, we do this first step of training the model, we create the model, we train it, and we evaluate it. But in the real world scenario, then we have to move to production use cases. So we have to serve the model and being able to use that model for making inference with other datasets. So we are going to see how we can take care of this within the platform. At the same time, when we are serving the model and when we want to use it in production, we also have to monitor the performance of the model. And this is important because the performance of the model can change when the data that we use for inference changes. And in line with this, we have to monitor if drift is detected for the dataset that we are using or if any concept drift is being detected for the models. And I'm going to explain a little bit on this later on. So if drift is detected, then we have to retrain the model because the model will not be accurate enough for being used in production. But if we don't detect any drift and our results concerning monitoring are okay, then we can store the model and then include it in a model repository. And this is how the whole life cycle can be seen. So let's analyze it step by step, taking a look to the different features of the platform. And first, I have highlighted here the data. And as I have mentioned, when we are building this AI-based application based on the use of data, we have to have our data. And it's the most important step at the beginning in our same environment in which we are working. So how can we take advantage of this platform for this purpose? First, using a storage provider. In this case, we are using Nextcloud, and each user that is logged in the platform and that has the proper access have a Nextcloud instance with 500 gigabytes storage per user. And this storage can be synchronized using this Airclone tool in order to synchronize your data that you have in your storage provider with your deployment in which you have your computing resources and in which you can start training your model. On the other hand, an interesting feature that is available in the platform is that you can also import different data sets using the DOI, using the URL, to your development environment. And here you have an example in which you can access to different data sets that are in different Zenodo communities. You can access it, or you can access to other repositories using the DOI. Then these data sets will be imported to your development environment. Also, then we have the data processing step, and in order to do so, first we need to have the development environment, and then you can perform all the steps of curating, cleaning, documentation, and so on and so forth. But also here, I wanted to highlight other tools that can be seen a little bit of, let's say, data processing, and is when, in some cases, we are dealing with images, with videos, and we want to make segmentation tasks. In that line, we may need to annotate the images and label the different segmentations that we have made in the video or in the images. And within the platform, we provide users with this tool that is known as CVAT, which comes from computer vision annotation tools. And this tool has the feature for automating the labeling of different videos, images, and making that annotation process easier for the users. And this can help when we are dealing with segmentation tasks, when we are working with the data. So here you have an example on how we can segment an image using this tool. So now let's assume that our data are ready. We are ready for started training the model. So first we have this question here. Okay, do I have any model available for retrain? So if the answer is yes, we can access to a model repository, take a reference model, and fine-tune it. So within the platform, you have this possibility of retraining a model, of making fine-tuning, or even using incremental learning. So here I have included an example in which you can find a model that is based for plant species classifier. And this model, as you can see here, has been already retrained. But if you are working with a similar example, we can try this model, we can deploy it, and you can retrain it even with your new data sets. So in order to do so, you can configure your new development environment in which you will have this model here as an example, and then you can ask for the resources that you may need in terms of CPU, in terms of GPU, the GPU model that you need for this retraining, etc. However, in other cases, we may deal with the case in which our application will be quite different to the models that we have in our reference model, in our model repositories, and we want to create our model from scratch. Or even if we are just testing and trying to make some new applications, and we want to start from scratch for the creation of the models. In that line, as I have mentioned, we need to use simpler interactive development environments for developing these kind of applications. And within the AI4EOSC platform, users can choose to use, for example, Visual Studio Code or UPython in order to be able to develop the models in a quite intuitive way. So here you have this first example in which you can see how we can ask for a certain number of CPUs, we can ask for GPUs, and then we can select the development environment that we want to use. For example, here you have an example using UPython in which you can develop your models, but also you can get access to this Visual Studio Code development environment to develop your AI application. And this is done in a quite easy way and a quite transparent way for the user. Here we move to the train, and we can train the model, let's say, in a simple way. If we have created our development environment, we can train our models, we have enough resources, we have our data synchronized, and then we can train using different frameworks such as PyTorch, TensorFlow, etc., etc. Also, we can make the retraining, as I have mentioned, the fine-tuning, the iterative learning. We can, if we are dealing with a huge amount of data or with a quite big model, we can make a parallel training using multiple GPUs, using distributed training, using distributed learning with data parallelism. And an interesting feature that is available within the platform for the training and has a special focus on privacy-preserving machine learning is a feature that is for allowing users to make federated learning trainings. In addition to making available the use of a federated learning server, so we can enhance collaboration between different data owners that want to make a model, they want to collaborate, but they cannot share the data. We provide here from the platform this federated learning server that allows to make these machine learning models in a decentralized way. So users don't need to centralize the data, and they can manage these experiments using the dashboard of the platform, as I have already shown you. And the most important, interesting, part here is that if you are dealing with sensitive data, you may not want to upload your data to the platform, of course. So you can use the platform so in order to manage all the experiments, but with the data deployed in external cloud machines, in your local computers, or as you wish, also including authentication and different privacy-enhanced technologies that are available. So you can find this federated learning server, start it, run it, and then connect the different data owners. This is concerning the training. There are some of the lot of tools that are available. I have highlighted some of the most important ones. And then when we have already trained our model, we evaluate it using the development environment that we have, and we have tested that the model is accurate enough, then we want to move to the part of serving the model. So in order to serve the model, in AI4EOSC, we have an inference service, which is based in Oscar, and it's used to serve the AI models for inference. So that's what we call the AI as a service method here in the platform. So with Oscar, we support 2 serverless event-driven execution modes, and also you can deploy your models in production using the serverless environment, which is using Oscar, but you can also use it in a dedicated server or on a short-lived demo endpoint, which is what we call the try me endpoints, or even using dedicated instances just for prototyping. In addition, in this same line, we provide users with the support for building more complex AI-based workflows using composite AI techniques. And in order to do so, some of the techniques that are integrated in the platform are FlowFuse, RLIRA, for making this AI4 compose. I'm not going to enter so much into detail in this part because the next webinar that we are starting organizing for the next month of April, we will focus, among other things, in this part of how to serve a model, how to use these inference platforms, and how to take advantage of it. So here you have some of the examples in which you can see, okay, here I want to make inference using Oscar, I want to make inference using the Nomad cluster or using my own cloud resources. And also the AI inference workflows, sorry. And now when we are serving the model, we have to monitor the model also when we are working with it before putting it into production. So when we monitor the model, I have mentioned that we can apply different practices, such as first, I apply MLOps, that are an engineering practice that aims to automate the machine learning lifecycle. And in order to work with the machine learning operations and to follow these monitoring processes within our AI4EOSC platform, we have deployed in a quite simple way for the users ML flow tracking server that you can access it here. And then you can streamline the development of your models, track your experiments, package your code, and make reproducible runs. That is quite important when we are monitoring our models. And then we can also share and deploy the models in production for making inference, wherever. And in order to do so, we have more services, but I have only highlighted two that are the ML flow models for managing the models using a wide variety of machine learning libraries, model serving and inference platforms, etc. But also the service for ML flow tracking for tracking the experiments, compare results, compare the parameters that we have in each experiment, and so on and so forth. And again, I'm not going to stop more in this part of MLflow because in our webinar from April, we will also talk about machine learning operations and how to use MLflow from the platform. So now I'm almost finishing this machine learning lifecycle with the part of drift detection. So in most of the cases, when we are working with machine learning models that are based on data, monitoring the models could not be enough because models are learning from data and the data is not stationary. And that means that, for example, if we are dealing with time series, the data can change when the time changes. When we are working, for example, with data related to weather conditions, it will not be the same if we train the model with different characteristics in some months than in others. So in order to take care about this, within the platform, we have this Python state-of-the-art library for drift detection for detecting both data drift and concept drift. And again, we will talk about this in our next webinar more in detail because it goes hand in hand with the part of MLOps. And we will use this, well, users can use this platform for monitoring drift in their machine learning systems. So I'm going to briefly showcase the platform and then we can see the different features that I have mentioned. So here you have the dashboard, that is the part that the users can access. And then, for example, say, okay, I want to perform a federated learning training. I can access to this federated learning server. I can deploy it using different services. But if I want to retrain a model, then I can select, for example, a chest X-ray image classifier, and I can retrain it with my data, or many others applications, for example, based on artistic style transfer, also based in classifiers, but for sound, not for images. You have here different models that can be used for developing your applications. Or, for example, here, detection of different, let's say, objects in images. But in addition, here you can find the different capabilities, the different features that I have mentioned, such as the inference, the try-me endpoints. Here you can access to the storage, which is Nextcloud, as I have mentioned, or you can access to the MLflow instance for experiment tracking. And I think that one of the most important part that we have to highlight is that when we start working with a new platform, with a new server, with a new framework, accessing to having a quite detailed documentation is quite key for our development. So you can take a look to the documentation of the platform. There are a lot of getting starting examples, a lot of frequently asked questions. And as you can see here, in this table of contents, you have a lot of how-to guides on, for example, things that I have mentioned, how to make a federated learning training, how to train a model, which is like the most, if you are going to start working with AI, okay, how can I train a model from the dashboard then? You have here a guide, but also on how can I develop the model. So coming back to my slides, here you have this part of the documentation, how to register an account, which is a mostly frequently asked question. But also, you can access to our YouTube channels to see different tutorials. From these short tutorials, you can see here 1-minute tutorial explaining, okay, launch a train me endpoint or launch a new development environment, to more complete tutorials such as how to make the federated learning training, how to deploy your AI-based service using Oscar for making inference, or how to use Elira for AI inference pipelines. So you can check these tutorials if you are willing to use the platform and to understand how to work with it. And also, we are now in a webinar, but we organized 3 other webinars last year, so you can also check it for more info. So now I'm going to conclude by summarizing how is AI4EOSC empowering scientific research. And first, it's empowering scientific research, of course, in AI by providing users with this set of advanced AI tools. And I think that I have summarized most of them, but we can start from the beginning. Okay, we can retrain a model, which is a quite straightforward feature because we can access a reference model and then retrain it to our dataset, but we can do it within the platform in a quite easy way and with a wide catalog of models available. Also, we have this feature of making the federated learning trainings with the support also for other privacy and ANSEC technologies, because as we care about privacy, this is quite important also in order to enhance the collaboration, to foster the collaboration specifically within the European Open Science Cloud. Also, when you are working with, let's say, big models, or simply you are dealing with a lot of data for your training, we may want to parallel the training using multiple GPUs. And in the documentation of the platform, you can find how you can do it using different frameworks. Also, an important part that in some cases is when we are making research, we think about, okay, I'm going to develop my model, I want to evaluate it. But the process doesn't end with evaluate the model. So we have to monitor the model to check that the model is working fine. And in order to do so, we have these features for machine learning operations for drift detection. And then we can move to serving the model for making inference and for deploying it in production. In order to make all this stuff, specifically for the part of developing the different models, the users are provided with this simple and intuitive, such as the case of Visual Studio Code of Jupyter Lab, and they can ask for the resources in a quite easy way, as I have shown you in a screenshot. Then you can also deploy your models using serverless environment, but you can also use your own resources for these purposes. And one thing that is quite new, I have just included one line for this because I know that the last presentation given by Álvaro, he will detail more about this, is that now we have included a feature in which the users can deploy their own LLM. So I know that Steven has received a lot of questions concerning deploying LLMs. So again, I have already mentioned it, but we care about privacy. And if you can deploy your own LLM, taking care of, okay, if I delete my chat, the information that I have used for chatting with my chatbot will be removed. Then if you are deploying your own LLM, then you can ensure that. So we provide the users with this capability, with a set of models that can be deployed, and then they can test using a user-friendly interface. So finally, of course, if you want to access to more information, you can, of course, check our website, or you can check the documentation, as I have already said before. And I think that's all from my side. Thank you very much for your attention. And of course, if you have any question.
Yes, Judy, thank you very much. It was a very good talk, and I hope everybody could again hear about AI4EOSC, those that has not before the opportunity to look into it. Again, I share now the Slido with you can ask the questions. So we'll go with the less questions this time because we have also two other talks. So let me see the most popular. Could we have a hands-on training session on what you are saying? Is it possible that AI4EOS organize that?
Yeah, we are now organizing the workshops. And as I have mentioned, we are going to make a workshop that will be on machine learning operations and inference and so on and so forth. But yeah, we plan to continue with the series of workshops. But in any case, in the workshop that we held last year, and the videos are recorded in the channel of the project, we already explained how you can train a model, how you can retrain a model, for example, an image classification model with your dataset, and also how to make the federated learning trainings. These videos and these demos are in the YouTube channel, and so much more tutorials are available.
Okay, thank you. There are 2 or 3 questions very similar, so I will put them together. So can we ask for access for trying the platform? Can we try the models of the platform? Yeah, that's two questions that I would expect immediately, right? So Judith.
Yeah, these are like the most frequently asked questions. So there are like different user access levels. So you can think as being the basic access, and then you will have the option of using a try model within your try the model in the dashboard, but then also you can deploy the model in your own cloud resources. And that's with only creating your account, you can access, and you can make this, of course, is like quite basic. But anyway, we have different, we already did an open call, and we collaborate with different external use cases. But just in case you want to make a try, if you're a researcher, you can contact us, you can reach us with our email list, and we will see a way in which we can collaborate, because other features like having this access to these GPUs, as you know, there are like for authenticated users, for different collaborators with the project. But anyway, as I have mentioned, we want to foster collaboration and scientific research, so you can send us an email and we'll see.
Okay, so sorry, I think because there are many questions, I'm sorry that I will not ask all. I'm checking the most popular that have some votes. What are the data repository integrations, if any? And I think we'll finish with this question. I know there are more, and there are also some high levels questions. Maybe we have chance at the end with Alvaro also to respond to them. So now we go just with this one.
Okay, yeah, and there are different open repositories that are integrated. Of course, the node that I have mentioned, but you can also integrate and synchronize data for Hugging Face, for Mendeley data. I'm talking with my memory because there are a lot of open available repositories. But anyway, I think that it was in my slide concerning this repository as OSF. It was also available. I think that also the models available from the bioimaging model 2 can be imported in certain ways. So most of the repositories that probably you are thinking of could be supported using the DOI or the URL. But anyways, in the documentation, you can find all the details concerning the repository supported.
Okay, thank you. I see one of the questions is rising, but we will probably respond to that better with Alvaro in the end about the difference with AI4EOSC and AI on demand, but that I think at the end, Alvaro will have also a chance to respond to that. So thank you again, Judith, now.
Thank you very much.
So we will move now to Yolviate demo in AI4EOSC platform. And this will be presented by Fahimek Albabek. She has her PhD in mathematics from University of Porto, Portugal, and won the prize for the best doctoral thesis in mathematics and computer science fields. She earned also her second PhD in industrial engineering, focusing on the application of AI in agriculture sector. She works at the data analytics, access and application scientist, specialist at the Karlsruhe Institute of Technology in Germany. So, Fahim, the floor is yours, please.
Thank you, Marcin. Let me share my screen. You can see my screen now, yeah?
Yes, yes.
Okay. Okay. Hi everyone. Today I want to show you how to use Yellow V8 in AI4EOSC platform with a really quick demo. You only look once, or Yellow is a real-time object detection algorithm using CNN. Unlike, for example, fast RCNN models, these models process entire image in one pass for speed and efficiency. And through years, the different version of this model was developed, and each new version improved the previous one in terms of accuracy or speed or both. Ultralatis is a company that develop computer vision models, and they are known for packaging and maintaining different versions of yellow models. The yellow models from Ultralatis can be used for different tasks like classification, which is identifying the object in an image, or object detection, which is detecting and localizing multiple object in an image with bounding box, or segmentation, which is identifying the exact shape and boundary of object in an image, which is pixel-wise classification. Okay, let's go to the AI4EOSC dashboard. In here, in marketplace of AI4EOSC, if you scroll down, you can find this general module Yellow V8 that we use this Ultralatis package, and we add the pass API to this Yellow V8. In the right, you can find this try button that Judith already explained about it. This try button creates a short 10 minutes deployment of Gradio that you can use and just test how the inference of this model works. Anyone can authenticate themselves in the dashboard with any account, and they can try this try me button. When you deploy this try button, you get a Gradio interface for Yellow V8. Yellow V8 support JSON output, PDF output, PNG output, or MP4. For this tutorial, we tried PNG output, and then we can upload any image. There are different parameters that you can play with, but we keep it as default. Then we submit our request. After a while, we hopefully have the output for the detection of the object in the image. We can also try other tasks like segmentation and submit the request. And then, yeah, we have the output for the segmentation task. There are two more buttons here, but these are available just only for the use case of the project. For example, they have their data set for the detection, and they want to train a model, this yellow model on their data set. They can go to this code space and create a deployment from this yellow module. Since we want to use for the training, we ask for the Jupyter. In the next page, we can configure the hardware. since we are going to train this model, we need GPU, and we can specify the model of the GPU that we need. We can also increase the RAM and disk memory. In the next page, as Judith already explained, we provide the user with the instance of Nextcloud as a storage, and they can use it to store their data there. In this page, the user can manually configure the Nextcloud, the access to the Nextcloud, or they can go to the dashboard and click. Sorry. Can you still see my screen?
We can see, but not this one. Yeah, okay.
Now?
Yes, yes.
Okay. They can click on their name and link the Nextcloud to their account. And then in every deployment that they create, they have this credential automatically added. As already Judith mentioned, we can also add a data set from different community of Zenodo. For example, here we have AI4EOSC project, and we can choose one of the data set that is provided by one of the use cases of the project, or you can use the supported DOI from different websites. Then when we add this data set to our deployment, it will be automatically downloaded to our Nextcloud account, and then we can submit our deployment. I don't know what happened here, but okay, I already have one deployment for this demo with the GPU attached to it. When the status of our deployment change to running, then we can go to this info, and we can see that this IDE button is activated, and we can click on it, and it redirects us to the Jupyter Lab. If it's the first time that you want to access to Jupyter, it asks you for the password that you choose during deployment. Since we create this deployment from Yellow V8 module on the dashboard, we already have the codes necessary for Yellow V8 and all the packages necessary for this Yellow V8, training this Yellow V8 are already installed. If we go inside this repository, we have this API directory, which contains all the code necessary for adding DPass API to the Yellow V8. We also have this Yellow V8 API, which contains all the code, AI related code. For example, in this process annotation, there is a script that you can convert the Pascal or CocoJSON format annotation to the format that Yellow accepts. Before you start training the Yellow V8 on your dataset, I recommend you to carefully read the README of this repository. Here you can read information how to use this ML flow for tracking your experiment, how you can prepare your data for different tasks, detection, segmentation, or classification, and which the different version of the Yellow V8 model, and how you can start the DPass API. As I mentioned, from this deployment, we have access to the onto our Nextcloud. We just need to go to this storage directory, and from there we can see all the data set that we have in our in your Nextcloud. Then the data that we downloaded during the deployment will be saved in this AI4OS storage. To train the model, we just need to start the DPass API. Okay, here we can see that it says that DPass loaded the yellow V8. We need to go to the dashboard again, click on the info, and here we can see this API button is activated. We click on it, and it redirects us to the Swagger interface. There are different parts in this Swagger interface. For example, we can, in the metadata part, we can get the metadata related to this yellow V8, which is the name of the authors, different information. For the training of the model, we can go to the train section, click on try it out. We can select between different tasks. For example, here, detection, we can select between different version of the yellow V8. Here we choose nano, which is the smallest one. And you have to specify a path to your data set. For this demo, I will use one of the data set that I already have on the Nextcloud. Okay, and we have yellow V8 has different hyperparameter during the training, and you can change this hyperparameter based on your application. The last hyperparameter, which is important, is enabling tracking of your experiment with the MLflow. You can activate this experiment tracking, and then you can execute the training. In this terminal, we can see that our training is started. After the training is finished, all this information will be saved in the MLflow instance. This is the MLflow instance that is provided by the project for the use case of the project. They need to go to the sign to access to the this instance. The use case need to go to the sign up page of the in this instance and log in with AGI check-in. After logging, the email that you use for the AGI check-in will be your username, and here in the password you can choose a password for this instance and then use this username and password to log your experiment during training. For this demo, I already have some run of experiments logged in the MLflow. For example, here we can see that during training of the yellow V8, we log all the parameters that you choose for the training of this model. We also logged the metrics during the model metrics during the training of the model. We have system metrics about how much memory, how much GPU you use, and we also log the model, the final train model. In here, we can also compare different runs with each other. If I select several runs, I can compare with each other, and then I can choose here that I want to see what's the difference in the parameter when I train it, which here is just this learning rate, and then I can compare the performance of the model during training based on mean average precision. Then after this, for example, I can say, okay, this model shows better performance, and I can go to that experiment. For example, this one, and I can register the log model in my model registry. In the model registry of ML4 for this model, I already have 24 version of this model, but I changed the alias of the version 18 to champion. That means this is the model with the best performance between these 24 version. I think, yeah, our training is finished, and it's logged all this information in the MF flow. This is the one that we already trained. Okay, the next thing that I wanted to talk is the other button. Sorry, I logged out from this deploy button. Here we can have inference service from this yellow V8 model. Judith already explained that we will have one webinar about Oscar, and we can also have inference service using resources on the dashboard, and or you can use your resources from your own cloud. Here I will use these resources from the dashboard, create another deployment. Since it's just for inference, I don't ask for the Jupyter. I don't change anything in the hardware configuration, and I don't need dataset, so I just submit my request. I think, yeah, I already have one deployment running for the inference. If I click on the info, I can see I have again this API button, which again redirect me to the Swagger interface. In the last part, I have this prediction part for the yellow, and then similar to the Gradio interface, I can do execute the inference. Here, the output is just the JSON file, which is the name of the object that I have in the picture, and the coordinate of my bounding box. The other button is the UI, which is again the Gradio interface that I already showed you during this using try button. Is the same, so I don't try it again. Okay, as I mentioned, this yellow V8 is a general model, and a user can use it and train it on their dataset. We already have some use cases from another project. I imagine that they already use this general module yellow V8, and they train the model on their own data set. For example, this one, OPSI, is one of the use cases of I Imagine project. They already use this yellow V8 that I mentioned, and they trained the model to detect fish from video from underwater. I think that's all I wanted to say, and thank you for your attention. If you have any question, please ask.
Thank you very much for this presentation, Fahimah. I think it was very interesting and very more in details. You are now sharing the screen. I will start share the Slido again with you can ask here the questions, please. And basically, if there are any questions to Fahime, please. I don't see for the moment questions coming. It has to be very clear what you have been showing. Then I think probably there was a question like last time, can people try themselves that? And I think this was already replied by Judith that in general we should be contacted for that. Okay. I don't see for the moment other questions coming. Let me maybe refresh. If not, yeah, how can I add my app based on YOLO version 8? And so that's the first question.
As I mentioned, you can use this Yellow V8, train your data, train your the Yellow V8 on your data set, and then to add it to the marketplace, you have to contact us. We create a repository for you, and we make you admin of that repository, and then you can add the weights of your model to that repository, and then we publish it in the marketplace.
Okay, thank you. And the next question, I think, okay, we have a couple coming. YOLO 8 can be used for classification, segmentation, or both.
It can be used for detection, segmentation, and classification, but you have to prepare your data based on the task that you want to do. And this preparation are already explaining how to prepare your data for each task in the README.
Okay, thank you. Next question is, what is the best approach to use YOLO-based version on a large amount of images?
As I mentioned, we have this Nextcloud storage. If you are a member of the project, you can have access to the storage, and you can save your data set in this Nextcloud instance, your Nextcloud account, and then from this deployment, you have access to the data set, to this Nextcloud, to your Nextcloud account. And so even you have a large data set, you still have access from your deployment, and you can train it easily from the dashboard. I hope this replied the question.
Yeah, so thank you again, Fahime. I think that's all the questions. There are more, but I think they are actually for next talk already, the questions coming. So I think Alvaro will have a couple of questions to respond. So thank you again. And basically, we are now moving to LLM4EOSC in action by Alvaro Lopez Garcia. That is CSIC tenured scientist at Spanish National Research Council. He's head of advanced computing in a science group and the project coordinator for AI4EOSC project. He holds a PhD in science, technology, and computing from University of Cantabria. And in the last year, he was working on adoption of cloud technology by scientific data setters users, delivering innovative services for science and research under the EOSC ecosystem. So welcome, Alvaro. The floor will be yours. Just to tell you, you will have one question. Is the tool open to anybody who can deploy LLMs? And I hope you will also somehow reply in this talk for this question. So please, you can start.
Hello, Marcin. I hope you can hear me correctly.
Yes, we can.
And that you can see my screen.
Yes,
so yes. I think this question will be answered during my talk, but otherwise I will be happy to catch it up later on. So after these three talks, I wanted to introduce to you our services that are focused on large language models and how we are dealing with that in the AI4EOSC project. Okay, first of all, just a very brief recap of what large language models are. As Stephen was explaining before, we can consider LLMs as advanced AI models that have been trained on a huge amount of textual data. But not only textual data, but basically we can consider them like that has a certain outstanding capabilities. They are able to understand human-like text, and they are able to generate human-like text. Therefore, they are able to answer questions accurately or to a given extent, as it was explained. They are subject to hallucinations and things like that, and they are able to help us in tasks that have to deal with text, like summarization, translation, or even content creation. I mean, these large language models are very common right now. Industries and companies are starting to use that for the most obvious things, like customer support, for content generation, for blogs, articles, newspapers, and even books. Language translation services are now leveraging more and more multilingual models for translation. As Stephen pointed out, there is an interest in research and academic, not only on writing assistance, as I put here, but also in other aspects. Regarding our context, LLMs for the European Open Science Cloud and for science in general, there are some potential benefits and positive impact, as it was introduced before my talk. They can enhance and help us in the research process by assisting us in some tasks where they sometimes outperforms a human being, like in text to summarization. They are able to digest a huge amounts of data of text and give us precise summaries, like proofreading of manuscripts, synthesizing existing knowledge base, and so on. Therefore, they are able to also help us in accelerating that analysis with code generation. Code assistants are more and more prominent, and therefore the coding processes are now being streamlined with AI, reducing a lot repetitive and prototyping tasks. As it was shown also before with these deep research tools, they are now they can also be considered as assistants for complex tasks, like guidance on some kind of research, like the management guidance in the management of complex instruments, digging into huge documentation bases. All in all, they are giving us a huge innovation potential. And therefore we cannot neglect that they exist, and then we need to start thinking in how to use them responsibly, and in how we can procure an infrastructure and the needed services to deliver them sovereignly. So these are nice features, but obviously there are some drawbacks. Easy access is needed from a research and science point of view, beyond just going into the commercial providers. First of all, why? Well, democratization. We need to make these powerful tools accessible to a broader audience that may not have access to commercial providers that, at the end of the day, if you go with the free versions, as I will see later on, this has some drawbacks that you need to take into account. Or if you go for the paid version, obviously you need to be able to pay for that. Also support. We need to give us tools that will help researchers that do not have access to these tools quite so easily. Obviously, we could think on an ecosystem where we have a collaborative LLM tooling, where we can easily share knowledge between open LLMs. And the most important concern from my point of view is privacy. Privacy, we need to ensure that our data remains private. We need to ensure our data sovereignty, and we need to be aware that using commercial providers in the free versions sometimes has some counterpart on the data usage. Moreover, beyond these access concerns, LLMs have an important infrastructure requirements that we cannot neglect. They need high performance computing, or at least some hardware that is performant enough in order to serve these LLMs at scale. We need to have scalable platforms that are reliable, that are able to deliver the LLMs predictions, the LLMs generated content at a scale, and that are able to scale up and down depending on the needs. And we also need to deal with user-friendly interfaces. We need to simplify the access and management for users that do not have enough knowledge to know what an API is, not to mention to deploy an API server. So we need friendly user interfaces. Regarding privacy, I have stolen this comparison from Steven, that is online in the URL that you can see here, and in regarding the protection, data storage, and usage complying with the GDPR, the data protection regulation in Europe. As you can see, the only company that is offering an LLM survey that is GDPR compliant, even in the free version, is Mistral AI, which is a European company. And therefore, they have taken care of being compliant with the GDPR. The other ones have an increasing level of privacy if you go with the enterprise version, meaning that you need to pay for them. The free version has some drawbacks, as you can see here in the privacy policy from one of these online services. Data is being collected, as you can see in the left-hand side. We collect your personal data that you provide to the input to our services, including your prompts and other content you upload, such as files, images, and audio. And how we use that personal data? We use that personal data to maintain our services, to develop new services, and to retrain and to give feedback to our models. Therefore, this is something that it is happening, and this is something that we need to be aware. And this is one of the main motivations that have driven the delivery of the services that I will present today. Also, the infrastructure challenges for deploying such services are large. The complexity of deploying LLM is significant. We need technical expertise both in AI and in distributed computing in order to deliver an efficient solution. We need to deal with large data sets and large computational resources. Although there are some self-deployment tools like Oyama that allows users to deploy models locally in a powerful laptop, in a workstation with ease, but obviously this cannot scale beyond personal usage with a small or medium-sized model if you don't have a large accelerator. It requires, why? Because as it has been already discussed, these LLMs has some hardware requirements that we need to be aware. We need high performance hardware in order to ensure this optimal performance and that the latency of the predictions is low. Also, something that it is sometimes neglected when somebody is deploying a service is that we need to maintain both the models and the technological stack up to date. We need to roll up ongoing updates because in terms of performance, new models can be more performant, but also in terms of security. Some models can leak information if they are not updated. Therefore, this is something that needs to be taken into account. And also the costs. Obviously, managing all of this has high costs in terms of personnel, in terms of hardware, in terms of maintenance, and can be prohibited for individuals or for small organizations. With that in mind, we have delivered two different sets of services that I'm going to present now. We have delivered LLM4EOSC and the ability to deploy your very own LLM within the platform. The first one, which is called LLM4EOSC, was introduced in November 2024. We announced that during the EOS symposium in Berlin. And it is a managed service offered from the AI4EOSC platform that is composed of two different components that are working together. On the one hand, we have a user interface. On the other hand, we have the API that is delivering the services to that user interface. The most obvious features is that you can explore the open source models that we are delivering via through the platform and also plug them with a knowledge base. You can create your own retrieval augmented generation infrastructure and your own knowledge bases and create your own customized models. This can be integrated with other tools seamlessly with LangChain or with any other tools that you can use for your workflow with some potential benefits. Obviously, you can, this is a shared service where the models are managed by the platform. Users do not need to deal with anything regarding deploying, managing the models. These are load balanced. The architecture that we're delivering is a scalable one where resources can be added if needed. With an OpenAI compatible API, therefore they can be used as a drop-in replacement for existing OpenAI compatible tools, and as I said here, is ideal for users that prefer a managed solution. A very simplified architecture. As I said, we have two different components. On the one hand, we have an API that is offering the vanilla LLM, so the LLMs that are just optimized without further modifications, accessible via API keys. We also offer a chatbot interface based on OpenWebUI that I will showcase later on, where you can use these vanilla LLMs. You can do the RAG via the interface. And once you have created this RAG and you have created this new model coupled with the knowledge base, you can also exploit a second API that offers these custom LLMs that can be also plugged into any existing workflow. The architecture is there at the bottom, but as I don't want to enter into the technical details, I can show you well how you can interact with the API via a curl using the console, via Python using basically requests a module. And before jumping here, let me show you how this looks like. This is the endpoint, the web interface of our service, where you can just log in with your credentials. You will be authenticated, and you can start asking questions to the chatbot and to the model. You can ask, for example, what is the European Open Science Cloud as a non-technical person, and you can see that it is starting producing the results with some accuracy. This is a vanilla model that has not been modified, but we also have here some other models that are available. We have a DeepSeek, a distilled version of Llama 8 billion parameters. We have an assistant for AI4EOSC, and here, for example, you can check how the assistant output looks like. In this case, we are not asking a vanilla model, so an unmodified or non-fine-tuned model a question, but we are doing RAG with the knowledge base from the AI4EOSC platform, and we are asking how we can deploy an LLM in the AI4EOSC platform. It is giving us, I will put it bigger, it is giving us the reply. You need to register and authenticate in the platform. You need to access the platform via the dashboard. You can deploy via the LLM as any other module, as I will show afterwards. This is again answering questions from a knowledge base. So we have the references where this information comes comes from, so the responses are quite accurate. Okay, we are actually exploiting this now for our platform. This is still not deployed. This is a beta service. We are using it as an assistant in order for our users to not read the documentation, but just ask questions to this chatbot and getting accurate answers on how they need to what steps they need to do, for example, to train a module here. This is the user interface I just showed on. Okay, this is the service that we have been offering since November as a preview service, because we are focusing on the technological stack that is needed to deliver these platforms and to deliver these models and to fine-tune the platform so that the models can be delivered efficiently. We are not focusing on developing models up to now. On the other hand, we thought, okay, this is nice, but we are just deploying models that we have optimized for our resources that we have, and we are just offering a limited set of resources. Why not allowing users to create their own LLM instances? This is a really brand new service that we have released this at the beginning of March during this week. And this is a new functionality that allows users to self-deploy a dedicated LLM stack based on the same components that I have showed on. So you can deploy a chatbot, you can deploy an API service, or you can deploy both of them via the dashboard with a few clicks, choosing from an initial set of smaller optimized models for our platform, like, for example, Llama 3B or Queen 7B, because obviously we have for this testing limited resources. You get your dedicated instance, you get less powerful hardware, but you have greater control and you can customize the model more. So if you need a tailored solution, this is what you should use. This is how this looks like. So let me again exit this one and come to our dashboard that it is actually telling me, okay, check out this new LLM tool that is available here. Okay, I can log in into the dashboard with my credentials. And once that I'm here, I can deploy the LLM as with any other module. Just click deploy. I can put the title. I can choose, for example, okay, this model, and I can put here the UI password that I want to use. I can submit it, and it is creating this deployment that for the time being it is queued because there may be that there are no resources. But in order not to hinder the demo, I have deployed this one beforehand, and I can enter here. And I'm getting an equivalent functionality, but just based on Queen 2.57b instruct model, where I can just ask, for example, I don't know, a fun fact about the Roman Empire, because this is an unmodified version of the OpenWebWe, and this is the default questions that are populated in the user interface. Okay. As a brief comparison between the both services, we have the LLM4EOSC service, which is a shared service multi-tenant integrated with the AI4EOSC authentication and authorization system, where some optimized models are offered and managed by the platform. They are offered via an API or via a chatbot service. Easy to use and ideas for users that just want to have a drop-in replacement for an existing commercial provider based on the OpenAI interface. You can also self-deploy your LLM stack, where you have a dedicated instance for you. which is private, with less powerful hardware, with limited resources, but with more control. I want to remark here that in both solutions, we have followed a privacy-first design. Therefore, no data is stored in a persistent way. No data is reused by the platform. The data that is uploaded here remains yours. Therefore, as soon as you delete your chat history, as soon as you delete your knowledge base, your data is wiped out. The models do not learn from the data that is uploaded. So this is something that I want to highlight. As a conclusion, the LLM4EOSC is open for evaluation because we want to understand from the technological point of view what are the needs in order to deliver LLMs in terms of performance, scalability, and reliability. On the other hand, the AI4EOSC platform now allows you to self-deploy your own private LLM stack in the platform resources. As I said, with limited resources, but you can self-deploy it on your own. And our next steps from the project regarding LLMs, we will continue the development and improvement of this kind of services in order to move from beta to production and make them accessible and usable for a wide range of users. We are also in the process of delivering our first fine-tuned models for the European Open Science Cloud that we will announce in the upcoming weeks. And we are also, as a different aspect, trying to foster the responsible usage of LLMs, because this is something that we cannot neglect. They are more and more used in a pervasive way in science, and we think that we need to use them in a responsible way in order to get the right benefit and the right impact of LLMs in research and innovation. So that's all from my side. Thank you for your attention, and I will be happy to answer any questions.
Thank you, Alvaro. I think it's a very important step. I think that was done also in terms of AI4EOSC. And so just a reminder where you can post your questions. Actually, we have a couple of questions and new ones and some older that are more and more being voted. So we'll start. There are a couple of questions more or less the same, saying who can use the LLM4EOSC service, and the second may be a bit related. How will this service be connected with EU and EU Node and also EOSC Nodes platform?
Okay, for the first question, regarding the first question, though, who can use the LLM4EOSC service? We are, since we want to streamline the deployment of LLMs, and we need to understand the technological requirements for this, we are only opening it for the time being to a restricted set of users. So this is not open to everybody, but it is just for users that request us access. In my slides, there was a link to with a QR code to a EU survey where you can request for this access, and we will grant it. Why are not we opening it in the wild, let's say? Because we want to get feedback from the users. We want to get feedback on how on the stability of the system, on the performance of the system, on the efficiency of the system. Therefore, we need to have a little bit of control on who is using that. Once we have streamlined this deployment, our idea, and this is now the answer to the second question, our plan, sorry, is to finish the integration with the EU or the EU Node or the EOSC authentication and authorization and identity system, meaning that you will not need to register into the platform in order to get access to these services, but any EU researcher will get access with their institutional credentials via EduGain into the tools. Obviously, they will not get the full functionality because of resources. We have limited resources, and we, as Judith was saying, need to ensure that those resources are used correctly and via agreements. But the preview endpoints, like the try me endpoints, like the chatbot and things like that, will be open for all registered users, and registered users will just came from Edugain. So it is in our roadmap to finalize. We have started that, the integration with the EOSC AI system. We are compatible with them. We just need to finish the configuration.
Thank you, Alvaro. So I'm coming with the next question. So because there are more and more coming, some LLMs can use CPU and GPU. How they look? How do they look at performance? How do they see the performance?
Yes, some LLM versions can use a CPU and not a GPU. Some quantized versions of LLMs can be run on more modest resources. At the end of the day, what you see is that there is a performance in the accuracy of the responses, but for some cases they might be enough. For example, for doing RAG, you can where you have a very good knowledge base, and you have a good set of embeddings that have been created, using maybe a smaller model will give you a good compromise between hardware resources consumption and the performance of the model.
Okay, thank you. Two last questions that are, rising, and they are even from previous ones. So one is for trying LLM locally as chatbots. How many computing resources do we need? What software or framework can be used?
To use them locally, well, how many resources? It depends on the model. This is something that it is hard to answer. If you go with one of the largest mixture of experts models, you need several high-end GPUs like the H100. If you go with smaller models, they can even run on a cell phone. Therefore, this is difficult to answer that question. Regarding the software, there are plenty of them. Like I personally like the Oyama one, plus the OpenWebUI. That both together deliver a good functionality, and they are easy to set up, but there are many of them. Currently, the landscape is sprouting, and there are myriads of different tools for using LLMs.
Thank you. And the last question that was posted before, but now are getting more and more votes, is about the difference between AI4EOSC and AI on demand. If you can say maybe something about that. And with that, I think we will finish our session, because I know there are more and more questions coming, but more or less we are at the time to finish, right? So.
Okay, regarding this question, the AI4EOSC and AI on demand, I think that we are serving different purposes. We see the AI on demand as a community effort to bring together different AI assets. And by asset, I mean something that is very broad in term, because the AI on demand is like an aggregator of services, platforms, data sets, models, experiment bundles, and so on and so forth. As a matter of fact, one of the components of their marketplace was an extension of our dashboard. And we see this as an ecosystem where different AI stakeholders are able to collaborate and to deliver and to integrate services and platforms like us. So we see this more like a platform, but not in the sense of a cloud compute platform as we are, but more of a collaborative platform where we can, AI researchers, AI technology providers, AI stakeholders in Europe can be mobilized together. So I think that we both can complement and are actually complementing each other in different terms. We are much more focused on the technology, on delivering a functional platform that can be used for by scientists with the context of open science and the European Open Science Cloud, and the AI on demand is more a collaborative and community thing.
Okay, thank you. I hope this clarifies. So yeah, I see next coming on the security and others. I don't know if you want to pick another question or we finish.
I can have another one or a couple
Okay, so the last one. As far as privacy and security are concerned, shouldn't data be retained for security reasons? What if this is an unlawful use? That's the question.
Oh, well, we retain data. Well, we do not retain data. We retain, obviously, server logs, accesses, and so on and so forth, as in any IT service that has been delivered, actually, for security purposes. So we retain who accessed the endpoint, at what time, from what IP, and so on, the usual server logs. However, the actual data that is uploaded into the platform, in order to be compliant with the GDPR, we cannot retain that as with any other service. As long as if you upload something to a commercial sync and share storage provider, if you delete your data, the data should be deleted right away, regardless of unlawful use. That's not something that we should deal with a disclaimer that, well, I am not a lawyer, but this is the usual procedure. It is like in an HPC center, you can upload whatever data you want there, but the data will not be retained. Therefore, if there is unlawful use, there should be further investigations, but this is not something that we care about. What we care is about your data privacy. Your data should remain yours. Your data should remain sovereign on the organization that has created it, and you can obviously upload that to a service to be used for building an enhanced model, but as long as you don't want to have that data there anymore, it should be deleted and it should not be reused without your explicit consent, not just clicking I accept on some privacy terms that nobody reads.
Okay, thank you. So with this response, I would like to thank you again for all your responses and your presentation. And I would like to thank you also all the other speakers of next webinar. And we would like to invite you as well to this. So thank you for today and have a nice rest of the day and good weekend.